Hi everyone and welcome to IB Methodology, your space for mastering IBDP mathematics. Today we are solving some IB past year exam questions step by step using a clear and exam oriented approach. This will help you understand the concept and score maximum marks. So let's begin. In this question, it says the line L1 has a vector equation this and line L2 has a vector equation this. And the condition given to us is these two lines are perpendicular and they intersect at a unique point. So we have to find values of A and B. So before solving the question, we have to first find out the direction vectors. So direction vector for line L1 is this and direction vector for line L2 is this. So we will first write the direction vectors 0, A, 1. For L2, the direction vector is 1, 2 and 3. Now we will use this condition that these two lines are perpendicular. It means the dot product of these two direction vectors should be equals to 0. So once we equate it equals to 0, so I can write plus 3 is equals to 0. My A becomes minus 3 by 2. So we got our A value. Now to find the value of B, we have to use this condition that they intersect at a unique point. Since they intersect at a unique point, it means both lines x, y and z values should be equal. So if I am equating my x values, I will get 4 is equals to 1 plus mu. For y values, minus 3 by 2 lambda is equals to 2 mu. And the last one is minus 1 plus lambda is equals to minus b plus 3 mu. Once we will solve these three equations, we will get mu as 3, lambda as minus 4 and b as 14. The question has asked for A and B value. So my A value is minus 3 by 2 and B value is 14. Now let's see this question. It says consider the homogeneous differential equation dy by dx is equals to this and we have to substitute y is equals to vx and we have to show that the solution of this differential equation is this. So we will first start by taking the condition y is equals to vx. We have to differentiate both sides with respect to x. So if I differentiate, I will get this. I have to apply the product rule. So differentiation of v taking x comma x constant and then taking v constant, we have to differentiate x. So its differentiation is 1. Once we got our dy by dx value, so now we can substitute this value into left hand side of this equation. So if we will substitute, we will get x minus y upon x plus y is equals to, if I rearrange, I can write it like this. Now I can substitute my y as vx in both numerator and denominator. So I can write it as x minus vx upon x plus vx. This will remain the same. And now I can take out my x common from left hand side in the numerator as well as in the denominator. So if I take x common, I will get 1 minus v upon 1 plus v, that is equals to x dx dv by dx plus v. Now I can shift this v here and I can take LCM. So first I will shift my v value and now after taking LCM, we will be getting 1 minus 2v minus v square upon 1 plus v, that is equals to x dv by dx. Now we will separate both the variables x to one side and v to the other side. So I will get 1 plus v upon 1 minus 2v minus v square into dv, that is equals to 1 upon x dx. Now we can integrate both sides because now we have separated the variables. To solve this equation, we have to use substitution method where we can assume u as this and then we will take differentiation of both sides with respect to v because now we have v variable. So I will get 2v. If I simplify this, I will get my answer as v. Now I am again writing the integral which I just got, 1 plus v upon 1 minus 2v minus v square dv is equals to, right side is easy to integrate. Now I will substitute this 1 minus 2v plus v square as u, and I will substitute my dv value as well. So I will get 1 plus v upon u. My dv value will be du upon minus 2 into 1 plus v. I can cancel out this. My right hand side will be the same. I can take minus 1 by 2 common. I am solving step by step. Now if we integrate both sides, we know integral of 1 upon the function is ln. So I can write minus 1 by 2 ln modulus u is equals to ln modulus x plus c. Don't forget to put this c. Now we will be using the condition given to us in the question as x is equals to 2 and y is equals to 0. So if I substitute these two values in the equation, but yes, before substituting the value, we have to replace this u by the original function. So I can write ln modulus 1 minus 2v minus v square is equals to, right hand side will be the same. Most of the students forget to substitute the value, so don't forget this step. Now my y was given to us as vx, so I can find my v value as y upon x. I have to substitute this v value into this, so I will get ln modulus 1 minus 2y by x minus y square by x square. My right hand side will be the same. Now I will be using this condition to find the c value. So once you will substitute y as 0 and x as 2, we will get our c value as minus ln 2. Now I will be substituting my c value into the answer which I got earlier, that is this is equals to ln modulus x minus ln 2. Now I can use log properties. In my right hand side, I will keep my left hand side as it is. This is my left hand side. So ln a minus b is equals to ln a upon b. Now I can shift this to the right side. So it will become my, first I will write my expression as it is. Now if I shift this negative sign over here, this will be minus 2 ln x by 2. Now I can shift this into the power and I can compare both sides. So by comparing the brackets of ln, I will get x upon 2 to the power minus 2. And to again change the power, I can write it like this. This will be 4 upon x square. I have reciprocated my minus 2 power. Now if I take LCM of the left hand side, this side, so I will get x square as my LCM. So x square minus 2xy minus y square is equals to 4 by x square. Now these x square will get cancelled out and I got my answer as this. This is what is the solution to the given homogeneous equation. Alright, that brings us to the end of these IB past year questions. If these solutions helped you understand the concept and exam approach, do give the video a like. If you have any doubt or would like to see more IB past year questions, feel free to leave a comment below. Don't forget to subscribe to IB Methodology for more clear and exam focused IB math content. Thank you for watching the video. I will see you in the next video.